Hey, welcome back to PSLE Math Lab. Today we'll solve a very interesting geometry problem. The diagram is formed centered around square ABCD, using each side of the square as diameter to form 4 identical circles. The 4 circles are inscribed within a bigger circle, which has the diameter of 28 cm. Take pi equals to 22/7. Find the area and perimeter of the unshaded part. If you would like to give this problem a try, please pause this video now. While looking at the diagram, we can have the following quick observations. Number 1, square ABCD sides is the diameter of the smaller circle. This was given in the question. Number 2 is that the bigger circle has twice the diameter of the smaller circle. We know this from the way the two smaller circles are inscribed within the bigger circle, centered around point 0, and drawing a horizontal line like this would also show us that relationship. Knowing the diameter of the bigger circle, with these two observations, we now know the diameter of the smaller circle and the sides of square ABCD. Now let's take a closer look at the unshaded area. We can observe that the unshaded area has actually 4 identical parts. Each part is highlighted in orange. And furthermore, each part, orange part, can be further divided into a semicircle and a weird shape, AOB, as highlighted in orange. We know it's not difficult to calculate the area of the semicircle. So to solve problem A, we just need to focus on finding the area of this weird shape ABO. So now we have a general direction on how to approach the question. Let us write down what we are given, what we deduce from our observations, and any formulas that can help us with our calculations. First of all, we are given that a bigger circle has a diameter of 28 cm, thus the radius is 14 cm. We also have 4 smaller circles with the diameter half of the diameter of the bigger circle, which is 14 cm, and thus the radius is 7 cm. Finally, we have the square ABCD with the sides equal to the diameter of the smaller circle, which is 14 cm. So let's write down some formulas that we've learned in school. How to calculate the areas and perimeter of the circle, and how to calculate the areas and perimeters of the square. So with this, we can move on to solving question A. So from our earlier observations, we know that the total area of the unshaded comprised of 4 identical parts. Let's focus on identical part ABO. So part ABO actually combines 2 parts. Part 1 is a small semicircle, and part 2 is an irregular shape formed by A, B, and O. Well, we can calculate the area of the semicircle pretty easily, which is half of pi r squared, and with r being the radius of the smaller circle. We calculate this to be 77 cm squared. Now, how do we tackle the problem of finding the area of the weird shape as highlighted? Well, we can simplify the diagram and focus on square ABCD and the 2 small circles. Can you tell that the area of the weird irregular shape is actually equal to the area of the square ABCD minus the 2 smaller semicircles divided by 2? We can calculate each of these pretty easily. Substituting 77 for the area of the small semicircles, we can calculate the area of the irregular shape, highlighted, to be 21 cm squared. And thus, we can easily calculate the area of the total unshaded area to be 77 plus 21, and then times 4. Before we jump into question B, let's explore an alternative and much more clever method to solve question A. Notice that we can shift the small semicircles part 1 into the square ABCD together with the irregular shape number 2 form part of the square. We can then do the same shift operations for the bottom semicircle, forming a complete square ABCD in the process. With this, we have combined 2 out of the 4 identical unshaded parts into the square ABCD, and thus we can easily deduce the total area of the unshaded part is equal to 2 times the area of the square ABCD, thus easily solving the question A. Isn't it just beautiful? So moving on to question B, we're asked to find the perimeter of the unshaded area. Well, zooming into the highlighted unshaded part, we see that AB forms half the perimeter of the small circle, while AO and BO each forms 1/4 of the perimeter of the other identical small circle. So together, perimeter of the highlighted unshaded part is the same as the perimeter of one small circle. So we'll have the perimeter of the unshaded part is equal to 4 times the small circle's perimeter. For each circle, we can calculate the perimeter easily to be 2 pi r with r equals to 7. And thus the 4 small circles perimeter is equal to 44 times 4 equals to 176 cm. And thus we solve question B. Before you go, I encourage you to try solve this bonus question. Can you tell that the orange and yellow part have the same area? Like and comment if you find this question interesting and have learned something new. And don't forget to subscribe and turn on the notification bell to keep up with our latest videos. Thanks for learning with us and see you next time.